Hi students, let's look at this question here, which was taken from the year 2018, paper 1 question 10 H2 math paper. You are given that an electrical circuit comprises of a power source V and a resistance R, a capacitance of C farads and inductance of L henries. Now the current in the circuit T after the turning on the power is I amps, and the charge of the capacitor Q capacitor is Q coulombs. Okay, the circuit can be used by scientists to investigate resonance, to model heavily damped motion, and to tune into radio stations on a stereo tuner. It is given that R, C, and L are constant. So these are pretty important things. R, C, and L are constants. So treat them as constants. All right. Then after which you have and that I, when I is 0, the current is 0 at time is 0. Okay, that's pretty okay. Now the first part is you're told to show under certain conditions where V, certain conditions on V, which will satisfy that equation there. So to show that, the first thing is you don't think too much, because you have a second derivative of second derivative of I with respect to t for what you are told to show. So you just differentiate with respect to t. Just get a second derivative and just think about it later. So differentiate with respect to t again. So use implicit differentiation for this part here. So we're gonna have now we are told that actually these three are constants, L, R, and C. These are constants, right? So if you differentiate this is okay. This is L. This would just be d square I, d square I, dt square plus R, di over dt. And because 1 over C is a constant, so this will be dq dt. That's pretty okay. And this will be dv dt. Okay? Now, once this is done, that's pretty. dq dt is given by I. We know that. So we could actually just replace this in since dq dt is equals to I. Okay, so this will be d square I dt square plus R di dt plus 1 over C I equals to dv dt. Okay, that's true. Now, so the question now is when would this be 0, right? So that's the question. So obviously, if this would be 0 when V is a constant, the voltage is held constant throughout the power source. Okay, so in other words, since dv dt is 0 when dv dt equals to 0 when voltage V is held constant. Okay, is constant throughout the circuit. The power source, the voltage is constant. So in other words, hence this will just be L equals d square I dt square plus R di dt plus I over C equals to 0. That's it. 2 marks. Okay, so I think the key point here is to state that the voltage is held constant, and also differentiate with respect to t to get the second derivative.